So in previous classes we have learned about the functional units and the operational concepts of a computer. While studying those topic, we have learned that we are having different functional units or components, and in order to communicate between those components we make use of a bus, that is a system bus. We have learned about that system bus. Now in this video you will be learning the different bus structures and how the data is being transferred, what is the elements that is being present inside this bus. All these things you will be learning in this bus structures. Okay, so for a computer to achieve its operation, the functional units need to communicate with each other. So what all are the functional units? These: input, output, memory and processor. So they need to communicate with each other so that they will be able to execute any instruction, or they will be able to perform some operation. So in order to communicate, they need to be connected using this system bus. So each bus will be having some parallel wires. It will be connected via some wires. So not a single wire, it can have many number of wires. A group of parallel wires will be there inside the bus, in which each wire will be able to transfer only a one bit of information. So for any in earlier classes we have learned that at a time some bits of information can be transferred from that is from memory to the processor, and that will be determines the word length. Okay, how many bits that forms the word can be decided based on the architecture of the computer, and that is called as word length. Number of bits that forms a word is called as the word length, and that will vary based on the architecture of the computer. So the number of parallel wires in a bus is equal to the word length of the computer, in which each wire will be allowed to transfer a single bit of information. So the group of wires combine together to form a bus. So next is like via this bus you will be able to fetch the data from the memory, isn't it? So in order to access the data from the memory, we need to know how the data is being stored in the memory, how the means how it is being arranged in the memory. Those things you need to know. So next is like memory location, addresses and the operations that is performed in the memory. So memory is like it consists of many millions of storage cells. Each can store one bit of information. So cells, it is divided into some number of cells in which each will be allowed to store one bit of information. So as I have said in the previous slide, like a word, one word is equal to some group of bits, and that group of bits will be vary based on the architecture of the computer. So data is usually accessed in n-bit groups, which is called as word, where n is the word length, and this n, it gets varied depending on the architecture. Anyway, here memory, it is divided into some number of cells. Each cell will be having one bit of information. So for any if the word is of 1 byte, means it will be having 8 bits. Okay, 1 2 3 4 5 6 7 8. So 8 cells will be having. So each cell will be having a bit of information, and how the cells is being arranged in order to store an integer or a character. That is shown in this picture. So here this in case of 32-bit word. Okay, here example is taken as 32-bit word. In such case, from B0 to B31, that numbering will be done like that. Okay, where B0 will be considered to be as the least significant bit and B31 will be considered as the most significant bit. MSB and LSB. Okay. In case of positive numbers, B31 will be taken as 0, and for negative numbers, B31 bit will be considered as 1. So this is the way you will be representing a signed integer. And then in case of characters, so for any character, it will be taking 8 bits. For any ASCII character, it will be taking 8 bits. So for any 32-bit word length which stores character, it is allowed to store 4 characters, where one character will be having 8 bits. Then accessing numbers, characters and strings. So number can be accessed via its word address. Character can be accessed via the byte address. Why? In the previous diagram itself, we can say that a single integer will be stored in this 32-bit word. So the whole thing will be considered as one word, which means that 32 bits. 1 bit is equal to 1 bit is equal to 8 bytes. Okay, so 32 bit will be equal to 32 by 8. So you will be getting 4 bytes. So if the starting address, that is if the one word is stored in some address like 1000, then the next word will be stored in 1004. Why? 1000, 1001, 1002, 1003 will be taking 4 bytes. Okay. In this way, you will be giving the address for each word. So for any number, it can be accessed based on the word address, and for any character, it can be accessed based on the byte address. Why? Here, one ASCII character will be taking 8 bits, which means that it is 1 byte. Similarly, second ASCII character 8 bits. So, which means that one character will be placed in 1000. So, the next character can be placed in 1001, then 1002, 1003, like that it goes on if we are accessing or storing any characters. Similar is the case with a string also. In this case, similar to the arrays where we are inputting some strings, here also the beginning byte address you need to mention. Means beginning byte address will be taken, which will be having the first character. Then in consecutive bytes, the next coming characters will be stored. So it is of variable length based on the string, and termination will be like either using some special control character or using a location, memory word location or register containing the string length as a number. That is, you will be sharing some length of the string, and when it reaches the length of the string, termination will be done, or based on some special control character. Now, how you will be retrieving this information from memory? That is, you need to get familiar with the bits, bytes, megabyte, like that terms you need to get familiar with. So 1 byte is equal to 8 bit. So, you need to keep in mind, that is, you need to remember these things. 1 byte is equal to 8 bit. And 1 word means, based on the architecture, it will be vary. So for a k bit address, it will be having 2 raised to k memory location. Okay, so for any if I am taking like 32-bit processor, means the word length will be taken as 32 bit. 32 bit word. 32 bit is the word length of any word. So in such a case, you will be allowed to store 2 raised to k number of words. Okay, which means that it will be having a 2 raised to k memory locations, and that is called as the memory space, and it ranges from 0 to 2 raised to k minus 1. So for any k bit address, it is allowed to have 2 raised to k memory location ranging from 0 to 2 raised to k minus 1 addresses, and that space is called as the memory space. And the number of words, how much it will be? 2 raised to k number of words. So if it is a 24-bit address memory, then number of memory locations will be like 2 raised to 24, which is 16 megabyte, where 1 megabyte is equal to 2 raised to 20 bytes. Okay. Then 32-bit address memory is equal to 2 raised to 32 memory location. For any 32-bit address memory, it is allowed to have 2 raised to 32 memory locations, which means 2 raised to 32 words can be stored, which is equivalent to 4 gigabyte, where 1 gigabyte is equal to 2 raised to 30 bytes. Then next, 1 kilo is equal to 2 raised to 10 bytes, and 1 tera is equal to 2 raised to 40 bytes. Next is how the arrangement is being done. So here we will be coming across a byte addressable memory and word addressable memory. So if data is arranged based on the number of words, then that is called as a word addressable memory. Usually addresses refer to the successive byte locations in the memory, that is called as the byte addressable memory. Okay. If successive bytes are assigned with byte addresses, then that addressable memory, it will be called as the byte addressable memory. And if words is being word addressable memory is being used, means data it is retrieved based on the word location, successive word locations. So either byte or word will be used to assign addresses. Then word alignment, words are said to be aligned in memory if they begin at a byte address, that is multiple of number of bytes in a word. That is word